So for flywheels, we need to know often the moment of inertia given by I equals mk squared. So you've got that formula now. If you're not talking about the mass, you're talking about the moment of inertia. How do I get the moment of inertia? I need to know the radius of gyration. There's two formulae for that. I often need to find the angular acceleration, so we've used this formula already. The change in angular velocity divided by the time for that change. That's what that's saying effectively. And the torque is I times alpha, this formula we've already talked about. And the torque is this turning force. So if it's turning around this point here, the torque is given by that turning force. So if the force is trying to turn something, generally we write something like this, we'll have another one over here with it. So we've got two forces effectively trying to turn something. We talk about a torque. And another formula that's well worth considering is this, and it will come into problems. In any flywheel, there's going to be some friction. So we have to take into account the torque required to overcome the friction, so the friction torque, and the applied torque that we're applying to this flywheel to get it to accelerate. This is the applied torque here. So the total torque is the addition of the applied torque and the friction torque. Quite a straightforward formula, but it needs to be remembered. This is a physical situation. We're trying to get a flywheel to accelerate. We try and minimize the friction torque where possible, but the total torque we apply has got to be the applied torque to get it to accelerate plus the force or the torque required to overcome the friction force in this flywheel. So that's another formula to add to our list of formulae to do with flywheels.